Okay, 6.6 is all about analyzing graphs of quadratic functions. This objective is incorrect. It's about students being able to graph quadratic functions in vertex form and being able to convert standard form to vertex form. So first, let's talk about how we graph vertex form. What is it? Well, it's already giving us the vertex here, where the vertex is h and k. And this number out here, the a still determines if it's positive, it's going to go up, but if it's, I should say positive, it opens up, and if it's negative, it opens down. And other than that, we have our vertex, hk. So, what's our vertex here? Remember, if you look at the formula, there's a negative sign there. So it's always the opposite of what the h looks like. So here, the vertex is -2, 1. And on practice number 1, the vertex is +3, -4. And on both of these, we can see there's no negative sign out in front. So these are both going to open up. So let's just do them. Go for it. So let's go to -2, 1. There's the vertex, which means that this is my axis of symmetry. And now this follows the same pattern that we've been doing because there's no a term here. There's nothing in front of the x. So this is just a normal x squared pattern, which means as we go over 1, we're going to go up 1, because over 1, 1 squared. Over 2, 2 squared, which is 4. So over 1 each way, up 1, because that's 1 squared. Over 2, up 4, because that's 2 squared. And over 3, up 9, because that is 3 squared. And there you have your graph. So go ahead and graph this one, and I'll put the answer up in just a second. Okay, so what you should have done, you should have plotted the vertex here at 3, -4, and then you could have drawn in your axis of symmetry, and then from there you just go over 1, up 1, over 2, up 4, over 3, up 9, and it's going to follow that pattern both ways. And that's it. You've graphed that form in vertex form. Pretty easy to do when it's in vertex form. Okay, what I want you to do here, and I'll let you just play with this first, but I recommend that you color code these things. What I want you to do is to just graph all 3 of these using a T-chart. So give it a shot, see what they all would look like, make a bunch of different graphs, and see if you can figure out what the A does. If you want a couple more, you could even try a couple others. You can maybe see what happens when you do like y equals 3x squared, and what happens when y equals 1/3 x squared. Just try and see if you can figure out what happens when you change the a, because that's all that's changing in these is the a. And how does that affect the graph? So I'm going to let you just go ahead and try that, explore with that, and then you might want to pause the video because I'm going to put what these graphs should look like up in just a second. So you should pause the video now. Alright, so here's the 4 graphs. One of the bottom's a little messy. So here's your basic graph with when a is just 1. That's the one in black. When we put a 2 in front of it, we notice that the graph gets a little bit skinnier. In fact, the higher this number is, the skinnier this graph gets. And when we put a fraction in front of it, we notice it gets a little wider. And in fact, the smaller this number is, or the closer it is to 0, the wider and wider and wider and wider this gets. And then when it's negative, of course, that just has the same effect, but it points it downwards. That's all. So a -1/2 would have a wide slope, or a wide parabola, pointed downwards. And that's all the a really does. It just affects that shape. And important to know that a graph of y equals 2x squared plus, 2 is going to have the exact same shape as just y equals 2x squared. You're going to have the exact same shape. This is just going to change the location. That's all. So let's go to the next page. Alright. What we're going to do next is we're going to convert these functions to vertex form. And then from that we should be able to list all this information. This, though, the y-intercept, we get that at the very beginning. So that's already here. That's this number all by itself. So the y-intercept, that's easy. That's just -5. But now, let's find all the other information. Well, and I'm sorry, we can also get the direction really quick. Is that a positive x squared? It is, so we already know that this thing opens up. So that's pretty easy. But the rest we can get by converting it to vertex form. So let me show you how we do that. Let's rewrite the equation. Y equals x squared plus 8x. And let's put a minus 5 over here. We're going to give ourselves some room to complete the square. So before, when we completed the square, we took our b term, divided by 2. That would give me 4. 8 divided by 2 is 4. And then we squared it. Square it. 4 squared is 16. So I'm going to add 16 right here. But I can't just add a 16 to one side of an equation without doing something to the other. And what if I didn't want to add something to this side? How could I counteract this positive 16? Well, I could just subtract 16, because positive 16, negative 16, that's 0. And so I'm going to just add 16 and subtract 16 at the same time, throw some parentheses around here, and kind of ignore these guys for just a second, because now I have a perfect square right here. So I could actually write this as x plus 4, because 8 divided by 2 again is 4, squared. That's the perfect square. And negative 16, negative 5 is negative 21. And now what we have here is the vertex form of that equation. These two things are exactly equal. This is just what it looks like in vertex form. And remember, our h value is always the opposite of this. So if this is positive 4, our h is negative 4. So we're going to write for our vertex negative 4, negative 21. And that, of course, means that our axis of symmetry is just x equals negative 4. And that's really all there is to it. So, why don't you guys try this one right here. Pause the video. I'll put all the answers up in just a second. Okay, so I completed the square. Well, actually, before I did that, I noticed that it's positive, so I knew it was going to open up, and I saw this number all by itself, so I knew that's my y-intercept. And then I completed the square, separated it out, and I saw that my b term was negative 4. Negative 4 divided by 2 is negative 2. Negative 2 squared is positive 4. So I added 4 and subtracted 4 at the same time, because that's just like adding 0, which you can do. And that gives me a perfect square here, which is, I can rewrite as x minus 2 squared, and then negative 4 and 13 make 9. So that gives me a vertex of 2 and 9. Because remember, it's the opposite of what that number is, the same as what that number is. So there's my vertex, which gives me my axis of symmetry is x equals 2. Alright, so now we're going to take all of that and we're going to graph it. So we're going to write it in vertex form and then graph it. Now this one is a little bit different for a few things. One, that's negative and it's a 3. So it's going to take a few steps here. So follow along with me. Alright, we're going to do the same thing we've been doing. Rewrite it, y equals negative 3x squared plus 6x, and then write the minus 1 way out here. Here's the deal. We need to get rid of this negative 3, so let's factor it out. I'm going to factor out a negative 3 out of both of these, so I get y equals negative 3 factored out gives me x squared minus 2x. And then I'm going to leave room to put in a c term, and I still have a minus 1. I haven't changed anything yet. So, let's figure out what my b term is. It's negative 2. Negative 2 divided by 2 is negative 1. Negative 1 squared is 1. So I'm just going to add a 1 here. Now you would think that would mean that we're going to subtract 1 out here, but we didn't really add a 1. Look what we added. We added a 1 that's being multiplied by negative 3. So we really added negative 3. So out here we need to add a positive 3. Alright, that's the part that's really tricky to everybody, but think about what we really did. It looks like we added 1, but we didn't. We really added 1 times negative 3, which is negative 3. So we can rewrite this as y equals negative 3. Perfect square is x minus 1 squared, and 3 minus 1 is 2, so plus 2. So we got a vertex. So maybe want to write that. If we write our vertex is 1, 2. We know this thing is going to open down. We know that it has a y-intercept of negative 1. And we know that it has an axis of symmetry of x equals 1. So now let's put all this together. This is what we mean by analyzing a graph. We can put all this together to actually graph it. So I'm going to do the axis of symmetry first. That's at x equals 1. Draw that in. I'll put in my vertex, which again is 1, 2. There it is. Y-intercept is at -1, so let's put that in. And now let's zoom in and put some other points here. Well, the axis of symmetry gives me free reflection points. So if this is a point, then one on the other side of the axis of symmetry must be a point as well. And that's kind of enough to just get a pretty rough estimate of a parabola here. One other thing that we could do, though, is I said earlier that every parabola or quadratic that has a -3 times an x squared looks the same as this one. It looks the same. So, looks. It's not the same, but it looks the same shape. So let's think about this. As I go over 1 left or right, I'm going to square 1, and that's 1 times -3 means I'm going to go down 3. So what happens here? Well, as I went over 1 left and right, I went down 3. Hey, look at that. So then, what happens if I went over 2? Let's just think about it real quick. Well, 2 squared is 4, times -3 is 12. Well, that means that if I was to go over 2, I should go down 12. And that is actually what happens here. So I could even get a couple more points on my parabola. So, there we go. I want you guys to do all the same thing for this next one. Find all the parts. You may want to pause the video because I'm going to put the answer up in just a second. Okay, so doing all the same stuff here. I rewrote it, split it apart, factored out that 2, giving me 2 times parentheses x squared minus 4x. -4 divided by 2 is -2. -2 squared is +4, so I added a 4, but I didn't really add a 4. I really added a 4 times 2, which is 8. So I'm going to subtract 8 out here. 15 - 8 gives me 7, and this whole thing gives me a perfect square of x minus 2 squared. So that means my vertex is +2, +7. I already know that my direction is opening up because this is positive. I already know that my y-intercept is 15 because it's right here. And now I know that my axis of symmetry is x equals 2. So I put all that in a graph. Now my graph wouldn't fit on this paper. So what I did instead is I made each one of these lines worth 2 instead of just 1. I kept my x values all just in the 1s digits, but these are 2 units each. That lets it fit on my graph. So here's 2, 7. And here's my y-intercept at 15. Here's my reflection point at 4, 15. And I got a pretty good graph here. Now, notice this looks like it's not so abnormally shaped, even though there is a 2 there. It should be skinny, but in reality, it is skinnier. We've just kind of shrunk down the graph when I changed all these values. So, that's it for that one. And now I have one more problem on the next page. Okay, for this one it says write an equation for a parabola given the vertex and another point. Well, let's start off with what we know. We know that vertex form is y equals a x minus h squared plus k. And as we look at this, we actually have a lot of these parts. Like this is really an h, this is really a k, and this is a temporary x and a temporary y that we could plug into this whole formula. And so let's just do that. Well, my y is 1. I do not know my a. My x is 2. Minus my h is -1 squared. Plus my k is 4. I'll just simplify this. I got a 1 equals a. Well, 2 minus a negative. That's like saying 2 plus 1. So 2 plus 1 is 3, and 3 squared is 9. So this is a 9, and this is a 4. So I'm going to subtract 4 from both sides. And I get -3 equals 9a. Divide both sides by 9. -3/9 reduces down to -1/3. So a equals -1/3. Alright, well, now I actually have everything to write this equation if you think about it. So I'm going to write y equals, instead of a, I'm just going to write -1/3 x minus my h. My h again is -1, so minus a negative is the same thing as saying plus 1 squared plus 4. There we go. There's my formula. Pretty simple to do once you have the information. So here's your h, your k, your x, your y. Plug it into the formula, solve for a, and then rewrite the formula. Try it all again. I'll put the answer up there in just a second. Yeah, go ahead and pause the video. Alright, so let's see what I did here. Plugged in all my things. There's my y, there's my a, there's my x, there's my h, there's my k. Plugged in, solve. 1 minus 3 is -2. -2 squared is 4, so that's 4 times a. -5, add 5 to both sides, you get 8. Then you get 8 equals 4a, divide both sides by 4, you get 8 divided by 4 is 2. So there's your a, it's 2. Then just rewrite the equation with all that plugged in, but remember your y and your x are still there, because that's what you need to actually have a function or to have an equation that you can graph. Alright, that's it for 6.5. See you guys on the next video.